Today, we're going to work experiment 1.3 from Module 1, a chemical reaction. If you've read the book or maybe you've performed some experiments before where you just make a physical change or you have a chemical reaction that causes a chemical change. So what we're going to do today is make a chemical reaction occur. So experiment 1.3 tells you to take some leaves, peel off. This is red cabbage. And I think I did 4 large leaves in a saucepan of water, about 2 cups, and boiled it for a few minutes. The result, this is so dark purple it looks black, but I've got almost 2 cups of cabbage juice. Anyone want to drink? Next, we have filled 1 balloon with about 2 tablespoons of generic baking soda, and I've got some vinegar here, white vinegar. So probably some of you have combined these 2 before and you know what's going to happen. Okay, so I'm going to use a funnel. Try not to make a mess. And it says to add about 1/2 cup of cabbage juice to the bottle. Okay, still the same color. The reason we use cabbage for this experiment, the juice it creates is an indicator solution. It will change color if there is an acid present. And then sometimes you can make it change back to purple if you add a base to it, something basic like toilet bowl cleaner. So next we're supposed to add, I've got measured 3/4 of a cup of vinegar. Let's go ahead and add that. And watch what happens to the liquid in the bottom of the bottle. Okay, it turns a pretty magenta color, bright pink. So the vinegar is very acidic, so this cabbage juice will change to pink if there is a lot of acid in the liquid we just poured in there. So it's almost red, so there is a lot of acid in white vinegar. That's why it smells bad and tastes terrible. Okay, so the baking soda will neutralize the acid. So the acid will not be present anymore because a chemical reaction will take place. Some of this component, some of the molecules and elements will turn into a gas when we add this baking soda to the balloon, the bottle.
Ooh.
So the balloon is inflating because a gas is being created, and the gas is carbon dioxide, CO2. So the more that is a byproduct of this chemical reaction, the fuller the balloon will get with gas. Okay, and notice what happens. It's all back to purple. So the acid has been neutralized. Gas is given off as a byproduct, and everything's back to the way it was. Okay, so we saw that when the baking soda hit the vinegar, the pink solution changed back to purple. It fizzed, it bubbled, and the balloon inflated. So this is the evidence for a chemical reaction because we have some gas up here that wasn't here before. So there's actually 2 chemical reactions. The first one occurred when the vinegar hit and the baking soda mixed up. So we had carbon dioxide and sodium acetate and water. Then the carbon dioxide, which is a gas, it bubbled out of the vinegar and up into the balloon. The second reaction occurred as the vinegar was being used up. So a substance like red cabbage has anthocyanin, and it interacts with the vinegar to form a pink color. Now, if alchemists were around years ago, they would think that they were able to just find the right recipe. They might be able to mix lead with some other substances and form gold. But of course, we know that's impossible. Okay, on this week's assignment sheet, there is 1/2 page of questions related to this experiment. You can find all the answers on page 13, and I think I've already answered them for you. All right, Module 1 dealt a lot with the history of science. We had, 30 different scientists you could study, which would have been enough material for a whole year, but we covered that pretty quickly. Module 2 deals with what is science, and then Experiment 2.1 is the first page of Module 2. Talks about what science is not before the book tells you what science truly is. So we're going to start off by learning a little bit about speed and falling objects. So how does the weight affect the speed of an object? We need a book, some heavy cardstock, cardboard, and regular paper. So what we're going to do in this experiment, we will prove that heavy objects fall faster than lighter ones. So what I'm going to do is hold the book and the cardboard at the same height and let go of them at the same time and see which one hits the ground first. You think I should let the cat out first? This would probably scare Charlie. Bye-bye, Charlie. Charlie's pretty afraid of loud noises. So here we go. 1, 2, 3. Okay.
That was loud.
So the book hit the ground before the paper, the heavy paper. Next, we've got some cardstock. It's not quite as heavy as the cardboard. And let's go 1, 2, 3. Okay. This one still hit the ground first, and it is heavier. What about this one? 1, 2, 3. Same results. So, we would tend to believe that heavier objects do in fact fall faster than lighter ones. At least that's what happened in this experiment. So there's another part to this, Experiment 2.2. We are going to add some more items to this experiment. I have a paper clip and a small rock. It needs to weigh less than the cardboard, so it should be really small. I didn't weigh these. I don't know. We're just going to roll with it, okay? So we're going to first hold the book in one hand and the paper clip in the other. Then we're going to repeat, this time with the cardboard and the paper clip will be next. The heavy paper and the paper clip will be next, and so on. Okay? Then we're going to substitute a small rock. Okay, so what do you think? Which one will hit the ground first? I don't know. We might have to do that in slow motion. It was pretty close. This time we're going to do the paper clip with the cardstock, the cardboard. I think it was closer, but did this one hit or this one? This one. Paper clip first. That's definitely heavier than the paper clip. 1, 2, 3. This time there's bigger difference. Still a paper clip. The lightweight paper and the paper clip. All right, even more of a time delay with the paper and the paper clip. Okay, so I'm going to flip back to the experiment and just make sure I do the rest of this correctly. So we've done the paper clip with all of the paper and the book. Next, we're going to substitute this small rock. Okay, and I guess we'll start with the book. 1, 2, 3. I would say it's a tie. What do you think? Videographer?
It was hard to tell.
Hard to tell. Okay. Next, let's try.
Maybe the video will show.
1, 2, 3. I think the rock beat the paper
Yeah,
at the time.
the rock beat the paper.
Cardstock. Who votes for the rock? I vote for the rock. Definitely the rock. And last, I think we know what's gonna happen here. 1, 2, 3. Okay. Now, we have some more throwing of objects on the floor. One more test. What are we gonna do? I think we wad up a piece of paper. So wad up the regular paper in the tight ball. This time use the book and the wadded ball of paper, then the cardboard and the heavy paper. What do you think?
Ooh, that was pretty close.
It's pretty close.
Yeah.
1, 2, 3.
Yep.
Okay, that time the
Wadded
paper
up
fell
paper.
faster than the cardboard, which was opposite of the way it was. And it was flat. Cardstock and paper.
Mhm.
Ha! So, well, this doesn't go along with what we concluded from the first experiment, does it? So let's read some detail about it. Likely, the book and the paper clip hit the ground at roughly the same time, and that's what we observed. Then we used the paper clip in the other trials, and most of the time it hit the ground first. It hit the ground sooner the lighter the object that we were throwing with it, like the lightweight paper, it took a lot longer. The cardboard, they were kind of really very close hitting the ground. So, what would we conclude? We would tend to think maybe the first experiment we had the wrong conclusion because we were like, yes, definitely we proved that heavy objects fall faster than lighter ones. But guess what? We don't really use science to prove anything. The conclusions are always tentative until someone discovers some new information that indicates we were wrong about a previous conclusion, then we just change our conclusion. We don't really use science to say that we've proved something. So in this experiment, the reason the paper took so long to fall is because of air resistance. So I'm going to post a video that I want you to watch of a feather and a bowling ball falling, just normal, when in normal air, and then falling in a vacuum, and compare how the two behave with air and without